We will now determine the trigonometric ratios using this given triangle. So this triangle is basically a right triangle as indicated by this little square. So first I'm going to mark the vertices of the triangle as A, B, and C. So we have this triangle which is a right triangle ABC. So first we have to determine this hypotenuse AC so that we can determine all the trigonometric ratios. So this can be found by using the Pythagorean theorem. So let's apply the Pythagorean theorem, that is square of the sides. Sum of the square of the sides is equal to the square of the hypotenuse. So therefore we can write the square of the sides as AB squared plus BC squared equals AC squared. Now we substitute the values AB equal 5. So therefore this becomes 5 squared plus BC is 3. This is 3 squared equals AC squared. 5 squared is 25 and 3 squared is 9. This is equal to AC squared. And this means we get the value of AC, that is 34 equals AC square. We then have to take square root on both sides so that we get AC. So therefore AC equals square root of 34. So we found the side or the hypotenuse AC, which we can mark it here as a square root of 34. So let's find each of the trigonometric ratios. First, let's find the sin x. Remember that we can use the so-called over, that is sine is opposite by hypotenuse, and cos is adjacent over hypotenuse, and tangent is opposite over hypotenuse. So for sin x, we have to use this sine, that is opposite over hypotenuse. So the opposite to angle x is BC. So I can write down BC over the hypotenuse is AC. So this becomes BC equals 3 and AC is root 34. We will rationalize this. We make it a little bit short. I'll just put it over here. So let's rationalize this. So we have to multiply by root 34 and divide by root 34. And when we do that, we get numerator is 3 times of root 34 over denominator is root 34 times root 34 is 34. So this is the sin x. That is 3 times of root 34 over root 34. Now in the same way, let's find out cos of y. So we are looking at this angle y. Notice that cos is adjacent over hypotenuse. So the adjacent side to angle y is BC. So we write down BC over hypotenuse is AC. So once again, we are getting this same relation, that is sin x equals cos y. So we can simply write down this as the answer, that is whatever we got for sin x, that is 3 times of root 34 over 34. So this is cos y. Now let's find out tan x and cot y. According to so-called over, tan x is opposite over adjacent. So the opposite side to angle x is BC and adjacent side is AB. So we can write down this as BC over AC. So this becomes a BC equals 3 and I'm sorry, this is AB. AB is the adjacent side. So 3 over 5 and this is the tan x. Now let's find cotangent y. Cotangent y is hypotenuse. I'm sorry, cotangent y is the reciprocal of tangent y. So we can utilize this so-called over as like this. That is, it is adjacent over hypotenuse like this. So let's put adjacent to angle y is BC and opposite to angle y is AB. So this becomes a BC over AB. So observe that this is the same as tangent of x. So you can simply write down this as 3 over 5. So this 3 over 5 is cotangent y. We will now determine secant x and cosecant y. Secant x is basically the reciprocal of cos y, cos x. So we have to use it like this in so-called over. So it is basically hypotenuse over adjacent side. So if we consider the angle x, the hypotenuse is AC. So I write down AC over adjacent to angle x is AB. So therefore this is AC over AB. AC is root 34 and divided by AB is pi. So therefore this is root 34 over 5 is secant x. Now let's find cosecant y. Cosecant y is reciprocal of sine y. So in SOHCAHTOA we can use like this, that is hypotenuse over opposite side. For angle y, hypotenuse is AC and opposite side is AB. So we write down AC over AB. So you can see that these two are equal, AC over AB, which means the result will also be the same. That is secant x is basically equal to cosecant y. So therefore we get root 34 over 5. And this is cosecant y. So we have obtained all the trigonometric ratios.